Good day, boys. Good day, girls. How are you? Hope you are ready for today's lesson. Hope you are well. Hope you are safe. So today we're carrying on with our math lesson. We're carrying on with our mathematics lesson, and then today we'll be looking at trigonometry. Specifically, be looking at trigonometric functions. Before now, we have been dealing with trigonometry. We talked about the SOHCAHTOA. We talked about different quadrants, angle on the Cartesian plane. Today we'll be looking at how to sketch trigonometric functions. Again, before we continue, my name is Sato Jafaru Abdullahi, and then we're looking at trigonometric functions today. All right. So at the end of today's lesson, you should be able to understand the trigonometric functions. So what are these trigonometric functions? What are the types of trigonometric functions? We have the sine functions, we have the cosine functions, tangent functions. And then we should also understand how to sketch the trigonometric function as well. Okay. Right. So trigonometric functions. So the graph of the basic sine graph. So today's lesson will be focused more on this sine graph. So we'll look more on sine graph in this lesson, and then next lesson we will focus more on cosine, and then finally we know that the tangent graph. Okay. So our lesson today will be centered more on the sine function. Okay. So generally we have the sine graph, which is defined as standard graph. We have got the standard graph. The standard graph as y equals to sine theta. Okay, that is the standard graph or standard sine graph. And then from this standard graph, we can now adjust it. We can now manipulate it. You can shift it to the left, you can shift it to the right, you can shift it upward, you can change the amplitude. Okay, we can double it. Okay, so but the standard graph refers to graph which was y equals to sine theta. And then for the cos graph, the standard graph is y equals to cos theta. And then for the tan graph, also y equals to tan theta as well. So but from those standard graphs, you can now make amendments, you can make adjustments, you can adjust it the way we want, the way we like. Okay. So the first adjustment, the first way of manipulating the graph is by adjusting the amplitude. Before we carry on, we have the value of your sine theta here is 1. So we say the amplitude is 1. So generally we say y equals to a sine theta plus q. Y equals to a sine theta plus q. So if you compare this with the standard graph, we said y sine theta is the standard graph. So now our coefficient here is our a. So here now we say y equals to be adjusted now that we can have y equals to a sine theta plus q. So the a implies the amplitude, and the q refers to the shifting of the graph, the vertical shift of the graph. Okay, a is amplitude, q is the vertical shift of the graph. So if you look at the standard graph like this, what is the amplitude here? So our amplitude here on the standard graph is 1. So our standard graph has a amplitude of 1. Okay. And then what is our shift now? That means what is zero shift. Now standard graph is not shifted. That means our standard graph is on the origin. It's sitting there on the origin. It's at the origin. It's not what shifted. Okay. So a standard graph, our amplitude is 1, and then there is no shifting of the graph of any kind. So that's our standard y equals to sine theta. You will see how this how it looks like as we go on the next slide. So we're saying in general terms, we say y equals to a sine theta plus q. You understand now? So now for the cos as well, we have what y equals to a cos theta plus q. Again, our a is our amplitude, and our q is our vertical shift of the graph from the origin. So if the graph is shifted, if you have here, for example, plus, you have here plus 5, it means that the graph has been shifted 5 units. The standard graph has been shifted 5 units upwards from the origin. And then if q, when our q is minus, if our q is minus, that means the standard graph has been shifted q units downwards. Okay, so q in both cases refers to the shifting of the graph, the translation of the graph vertically, either upwards or downwards. And our a refers to our amplitude. Our a value refers to our amplitude. Okay. Right. All right, guys. Sorry about that. Right. So we have that. So let's consider y equals to sine theta now. Let's start with sine theta. So y equals to sine theta. So let's see the graph of y equals sine theta. How does the standard graph look like? We're saying this here is the standard graph. Y equals to sine theta. Right. How does this look like? We're saying it's at the origin, we're saying it's at the maximum amplitude of 1. What is amplitude? You understand? We need to see. So now let's see now how do we sketch this graph y equals to sine theta? Because it's the basic. This is the basic, and from here we can extend, you can move a sheet, and then we can do other manipulations. Okay. Now, the following table contains a specific value theta and corresponding y values. For example, y equals to 30. Right. So now what we're saying is to sketch this graph. To sketch the graph, we're going to use, we actually have what we call the critical values. We actually have what we call the critical values. Okay. So the critical values, they are those important values that has to be there on your graph. That if you are sketching the graph, you must indicate the critical values on your x-axis. Okay, the critical values, those values that has to be there on your x-axis. You understand now? So talk more about the critical values as we go on the next slide. So, but what understand that critical values, when you say critical values, those values have to be on your x-axis, and for your sine graph, the critical values are 90 and the multiples of 90. That means on your graph, you must have 90. You must have 180, you must have 270 and 360. Okay, you must have 90. So you can have other angles, but more importantly, you must have 90, you must have 180, you must have 270 and 360. I mean multiples of 90. So these are the critical values that have to be that you must plot on your x-axis. So now, but for the sake of learning now, you know, just create a table. You're going to sketch. You're going to just use a lot of values. You're going to start off with a lot of values. You're going to start from 0 to 30, 45, 60, 91, 20. Just put these values from 0 to 360. Usually they will give you the elements of theta. They tell you the theta must come from 0 to 360. So that is usually the standard graph, where we have the values of the theta as what is 0 to 360. So now if the theta must go from 0 to 360, then we can have values of 0, 30, 45, 60, 90 in that step. In the steps of 30, 45. So these are the values we can have. But we say more importantly, you must have what 90, must have what 180. Okay, because in function, what we do, we sketch graph. We don't usually draw graphs. Okay, in functions, we sketch, we don't draw. Normally, to draw any graph, you need a table. Normally, to draw a graph, you need a table. You need to have to first of all complete the table. After completing the table, and then you have to then draw the graph using the values from the table. That's the normal thing. That is drawing a graph. But in function, we don't usually draw, but we sketch graph. We tell you sketch the graph up y equals sine theta. Sketch it. You understand? So that means we don't usually need a table to do our graph in function. We're going to sketch our graph without table. So that by sketching. So what you're saying is when you're sketching your sine graph, you may not have to use all these values. You may have to use like 0, 30, 45, 60, 90, all these values up to 180, up to 360. So what is more important that you must use, what must be there, at least it must be the critical values, the 90, 0, 90, and the multiples of 90, 90, 180, 270, 360. These are the critical values. But because of learning, because we are just starting to learn about the graph, that's why we're starting with the use of table. You see, we are starting off with table, trying to create a table. After we create a table, then we can plot the values from the table. Okay, so we're going to say our theta starts from 0 to 180. So if our theta can start from 0 to 180, so we can have steps of 0, 30, 45, 60, 90, 120, 135, 150, and 180. So sometimes I can tell you, draw the graph of sine theta, where theta is from 0 to 360, or where theta is from minus 360 to plus 360. So they can give you such kind of values, right? But on this table is basically from 0 to 180. So because we're just learning, so we are including all these other values, so our values of 30, of 45, of 60, of 90, of 120, of 135. So I mean, we are learning, so we are using table to start off with. But as time goes by, But we now have to draw the table. We just have to sketch the graph based on our understanding, based on the fact that we know about the graph. You understand now? So we are just learning. So we are starting off the table. So now the question is, we must consider this graph. We must draw a graph of what y equals to sin theta, where theta is from 0 to 180. So because of we are just learning, we are starting afresh. So we're going to start with, if theta goes from 0 to 180, so we are having these values of theta. Just come up with them. You can go in 30 instead of 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. You can go like that. So like that, now substitute the values. When theta was 0, you put sin theta, punch your calculator sin theta, sin 0, you substitute the values of theta so as to find your y. Remember your y is your sin theta. So to find your y, you put 0 by theta. Okay, you put 0 by theta. So sin 0 will be 0. In your calculator, you punch. Sin 0 is 0. Sin 30 is what? Half is 0.5. Sin 45 is 0.7. Sin 60 is 0.9. Sin 90 is 1. Sin 120 is 0.9. Sin 135 is 0.7. Sin 450 is 0.5. And sin 180 is 0. Okay, so with your calculator, you get all this. Okay, and don't forget again, we think we are learning, that's why you're using table. So from now, we're going to learn in such a way that we avoid using the table. We'll sketch our graph without using table. Okay, so as we go ahead, you learn better. Okay, right. So now carry on with that from 180. So let's extend it to 360. Okay, we have 210, 225, 240, 270, 300 up to 360. You find all the values. Okay, basically the values of our theta is ranging from 0 to 360. And these are the corresponding y values. So now with these two tables, you can now plot a graph of what? Y equals to sin theta. Again, the values of theta is from 0 to 360. So now, and these are our corresponding values for these angles. So we are going to plot the graph now. When theta was 0, y must be 0. When theta was 30, y must be 0.5. When theta was 45, our theta must go on the x-axis. The angles are always on the x-axis, and your y values is your numbers. Okay. On the y-axis, you have your number. On your theta axis, on your x-axis are your theta. You plot your theta, the angle theta on your x-axis. Okay. So now we need to plot this table now from 0 to 360 with all these corresponding values. Okay. So let's see how that looks like. Okay, we have this now. So if you are to represent that the table, so from 0 up to what? 360. And then we have this now. When x was 0, at 0, when x was 0, when theta was 0, y would be 0. When theta was what? 30. When theta was 30, y would be 0, when theta was 30, when theta was 30, y was 0.5. When theta was 30, y was what? 0.5. When theta was what? 45, y was 0.7. And when theta was 60, y was what? 0.9. And when theta was what? 90, y was 1. So it keeps increasing in that manner from 0 to half, from half to 0.7, from 1 to 0.9, from 9 to 1. And then after we start to decrease again. When theta goes to 120, it goes to 0.9. When theta goes to 125, it goes to 0.7. Coming down again. When theta goes to 150, it goes to half again. And then when theta decreases to 180, it becomes 0. So that means sin 180 it was 0. And when theta was 210, then it goes negative. Negative what? Negative 0.5. When theta goes 225, it goes negative 0.27. Going down more negative. When theta is 240, it goes negative 0.9. And when theta increases to 270, it's what? Negative 1. And then from 360, it starts to decrease again. So it goes up, it comes down, and starts going up again, giving all the sine functions. So that is what we are having here now. That at 0, it goes up. As it goes from 0 to 30 to 60 to 90, then it becomes maximum at 90, and the maximum value is just 1. So after the maximum value happens when theta increases to 120, Then it starts to decrease again up till it gets to 0. Where theta was 180, then we say y was 0. And then when theta was to 10, it goes negative, and then the negative goes on until when theta was 270. When theta was 270, gives us negative 1. The sine of 270 will give us negative 1. Okay. And then as we increase from 270 to 300 to 330, it starts to increase and we get our sine graph. So we call this one our sine graph. This is our sine graph. Okay. So that's our standard sine graph. Again, that's our standard sine graph. So with the sine graph now, what do we know about the sine graph? First thing we know that what the maximum value here is what? 1. The sine graph has the maximum value of 1 and a minimum value of negative 1. Maximum value of 1, minimum value of negative 1. And then what is our amplitude? How do you find our amplitude here? What are the amplitude? So our amplitude now, you say is what? The maximum minus the minimum divided by 2. Again, to find our amplitude, the graph, the sine, cosine, and tangent graph, we talk about amplitude. So what's amplitude? The amplitude was the maximum value minus the minimum value divided by 2. So the maximum value is 1, the minimum value is negative 1. So 1 minus 1 give us what? 1 plus 1, which is 2, and 2 divided by 2 is 1. We say the amplitude there is 1. And the amplitude of this sine graph is 1. Okay. So the amplitude is 1. How do you get amplitude again? You say the maximum minus the minimum, all divided by 2. 1 minus 1. So 2 minus 6 give us positive. So 1 plus 1 is 2. 2 divided by 2 is 1. So our amplitude for y sine theta equals to 1. Okay. That's what we wanted to know. Again, we said the maximum value is 1, the minimum value is negative 1, the amplitude is 1. Another thing to look at is the period. Another thing I want to talk about here is the period. So the period now, you ask now, what's the period of this graph? What is the period of this y equals sine theta? So the period of this graph is what? Is 360. So the period of the graph is that angle it takes the graph to go a complete cycle. So the period of the graph is the angle it takes the graph to go a complete cycle. Like here now, what angle does it take for you to make a complete? Like from here up to this point is a complete cycle. Like here, if it goes here, it goes up and come down, up to this point is it's like it's a half circle. So from here and down this way is another half circle. So if you put this top circle on top of this other top circle, then you have a full circle. Okay, so and then it takes what 360 for it to have a complete circle. So for a complete cycle or complete wave of the graph, it's called period. The end it takes for a complete cycle of a graph is the amplitude. So in this case, we see our period rather. Our period is the angle it takes the graph to go a complete cycle. So our period there is what 360. Okay, our period there is 360. Okay, so that's another thing to talk about, another property of that. So the graph of y sine theta has the following characteristics. One, that the maximum value is 1 and the minimum value is negative 1. Okay, a maximum value is 1 and minimum value is negative 1, as you have seen. Then another thing to think about there is the range. Talk about the range. So talk about the range. What do you mean range and domain? You understand what the range and domain means? Range means what? All the possible y values. Range means all the possible y values are your range. Range values are all the y values, and domain are all your x values. That you should know by now. When we say range means all the possible y values. So what are our range here? Meaning what are our y values? What are the possible y values we encounter in this our graph? So the range become what? From negative 1 to positive 1. From the smaller one to the bigger one is the range. So the smallest one, the minimum value, negative 1, maximum value, positive 1. So you see the range is negative 1 to 1. That is owned by range. Again, range means y values. Domain means refers to x values. So our domain here is from what? 0 to 360. That's our domain. Our range is from negative 1 to 1. Okay. So 0 to 360 is our domain. Domain implies the x, all the possible x values as it is on the graph. And then the range implies the possible y values as it is on the graph. So our y values will only range from -1 to +1. It can go beyond those 2 points. So this is our range, okay, right? So you're saying what, that the graph of y and theta have the following characteristics. One is that the maximum value of 1 and minimum value of -1, okay? And then the range is from -1 to +1. And then the amplitude of the graph is defined as half the distance between the maximum and the minimum. They have distance between the maximum and the minimum. You get your maximum, you get your minimum. So for the graph of y equals sin theta, the amplitude is equals half of 1 minus -1, which is equals to +1 here. That means 1 plus 1 is 2, half of 2 is 1. So they say the amplitude is 1, okay? Right. Now, we're saying now we can increase the theta now. So if you choose to increase the value of theta, in our initial graph, the value of our theta, our domain was from 0 to 360. But sometimes we can be asked to plot, we can be told that must plot the sin theta from maybe from -360 to +360, or from 0 to 720. So that can be changed. You can manipulate the graph even to that extent. Now, if we increase the value of theta, bring the value of theta from 0 to 270, in the graph we have it from 0 to 360, right? But we're saying now, if you have to increase it to 0 to 270, how would the graph look like? So if you have to increase it up to 720, so from 0 to 360, it ends here. And then if you want to increase, if you're told that the value of your theta is from 0 to 720, so that means that the double will be 2 of such complete graph, because it's saying the period for 1 is 360. So if your value of x, if your x values, if your domain values is from 0 to 720, that means you have what? Double of such sine graph. And it's going to look like this. Okay, going to go there and then it ends here by 360 and goes again up to 720. So you can have like this. And I said sometimes you can even have to do from -360. So you have negative values and positive values. So you extend on both sides of the axis, of the y-axis. So you can also have like that as well. Okay. All right. Now, let's see now. So now we're saying the period of the graph is what? Or the period of this graph is 360. So the period of the graph is 360. What do you mean by that? That means what? For graph to go in a complete cycle, then it needs what? 360. Okay. Right. So the graph of y equals and theta therefore is a cyclical in nature and repeat itself every 360. Basically, the graph, the period of sine graph is 360. Okay. Now let's see now. Sine graph, you want to change amplitude. So if you now have to change amplitude now, so the first thing you're going to make is the amplitude change. Now, before we have it as y equals to sine theta. Right. So if you now want to change the amplitude now, instead of being 1, we now have it as 2 here. So what change? If you have 2 here, what will change? In a sense, so what we change is the amplitude. That means the amplitude is what is going to change. The amplitude is going to change from 1 to 2. Understand now? So if you draw the graph of that, so now select a few values with corresponding x values. So now instead of using all those lot of values from 0 to 30 to 45 to 60, so I've said you can simply use what? Our critical values of 0, of 90, of 180, of 270, of 360 in multiples of what? In multiples of 90. So we don't have to. Now we trying to get rid of the table thing. Initially we use a full table. Now we are half table. So now from there you can go get the point whereby you can get the graph without even the table at all. So now instead of using those lot of numbers, you can choose to use theta 0. We can use from 0, 90, 180 to 360, and that will still give us what we want. That will still give us the perfect graph. So we use the values of what? 0, 90, 180 to 70, and find their corresponding values. So when you use the same values as well, you're going to get the same exact graph as we have got when we have used the whole lot of values. Okay. So now using theta as 0, so 2 sine 0, put the values in here. 2 sine 0 will give you 0. That can put in your calculator. And then, so 2 sine 0 give you 0. Then when theta is 90, 2 sine 90 will give you 2. And then 2 sine 180 will give you 0. 2 sine 270, when theta is 270, put 270 by your theta there. 2 sine 270 will give you -2. That you can put in your calculator. Okay, fine. And then when theta is 360, so 2 sine 360 will give you 0. So all this can get to your calculator. So now with these are y values now, for the values of theta from 0, 90, 187, 360, and their corresponding values, you can catch the graph as well. Okay, now we can start that now. So we are going to have just 0, we have 90, we have 180, we have 270, we have 360. And we refer to this as the critical values or critical points. You understand that has to be in there on your x-axis. If you like, you can have intermediate values, but these are important values you need to import. You need to have on your x values what we started with as the critical values. Okay. So now then you plot when x was when your theta was 0, your y was 0. When theta was 0, your y was 0. At theta 0, our y was 0. At theta 90, our y was 2. At theta 180, our y was 0. At theta 270, our y was -2. And at theta 360, our y was 0. So the same thing. So at theta 0, y was 0. At theta 90, y was not 2. We put here by 2. At theta 180, y was 0. And at theta 270, was -2. And at theta 360, it was 0. So with this now, you can now sketch your graph now. You now connect your points. You connect the point when it was 0. When it was at 0, you put a point here. When it was 90, it was 2. You put another point here. You plot a point there, and then when theta was 180, y was 0. There'll be another point here. When theta was 270, or y was -2, there'll be another point here. And then when theta was 360, y was 0, another point here. Then you connect a point and have a graph like this. Okay. So about this graph now, what can we say about the graph? So about this other graph, they can say what the maximum value is what? 2. The maximum value is 2, and our minimum value is for -2. Our maximum value is 2, our minimum value is -2. And then what our period now? What is our amplitude? What the amplitude in this case? As we said, our amplitude is what? The maximum value minus the minimum value divided by 2. So that will give us our amplitude. So to calculate the amplitude of this graph, we're going to say what? 2 here minus -2. So 2 minus -2 give you 4. So half of 4 give you 2. So our amplitude of this graph is 2. Okay. So what's the period of this graph? What's the period of this graph? The period of this graph will be 360. We're saying the period is that it takes the graph a complete cycle. So for you to go a complete cycle, the period is 360. Okay. So it takes 360 for you to go complete. Right. So that is that thing to learn them about the graph. So now, right, let's see on the next line. So let's say another example now. Sketch the graph of y equals to -3 sine theta for the interval of theta must go from 0 to 360. That theta is an element of 0 to 360. That means your value of theta must go from 0 to 360. So with this now, if you want to draw it, you want to have a table, which we don't have, right? So you're going to get values between 0 and 360. You have 0, 30, 60, 90, 120, 150, 180. But don't do that. Just use your critical values. Just your critical values of 90, of 0, 90, 180, 270, and 360. And plot in the values, put in your values of what? Put in the values of put the values, your theta values. So substitute those values into the equation. Okay. So, and then that is still a way of drawing. So you stay in graph, you don't even have to use the value at all. So what we need to do, we must just understand what this equation means. What does it mean? It means that what? That now this negative implies what? That our graph, our standard graph, has been reflected about the x-axis. Our standard graph has been reflected about the x-axis. That's the meaning of what? This minus here. So that means the standard graph y equals to sin theta Now it now have an amplitude of 3. So it has an amplitude of 3. This is our standard graph y equals to sine theta. Okay, we try to compare now. A y equals to sine theta is this graph here, which is the standard one. Now it's pulled towards, it's now made to have what? An amplitude of 3. So it's not stretched towards 3. It's made to have an amplitude of 3. And then after that, it's now what? Reflected about the x-axis. So the negative there implies that it was reflected about the negative x-axis. So that means what should be this here has been turned around about the negative axis, and then it flipped around here. Remember when you reflect something on x-axis, the y will go negative. So it flipped around and then we have this. Okay. So we're gonna end the class today at this point, and then next class we'll carry on from exactly this point. So we'll carry out our lesson exactly from this point, almost from next class. Okay. So we're gonna go over this other example, back to the example next class, and then we can complete the lesson. But for the time being, we can take this as our homework. Y equals to 3 sine theta, and y equals to minus 2 sine theta. So we should try to sketch this graph. Sketch a graph on the same set of axes. Sketch the graph of y equals to 3 sine theta, and sketch the graph of y equals to negative 2 sine theta on the same set of axes, where your theta is from 0 to 360. And then you must write down your maximum and minimum values for each graph, and then write down the range, write down the amplitude and the period for each graph. Okay, so thank you for listening. We're going to end our lesson today, and then enjoy the rest of your day.